One of the important research fields pursued in the Nuclear Physics Institute of the Czech Academy of Sciences is the use of ionizing radiation emitted by radioactive substances in diagnostics and therapy of various diseases. Biological effects of ionizing radiation were observed shortly after the discovery of radioactivity in the end of the 19th century. They were soon employed in therapy and later also in medical diagnostics. In this case, the radiation emitted by a radionuclide is used for diagnostics. The radionuclide must be attached to a molecule that transports it to the organ or tissue of interest. Glucose, labeled with one of the fluorine radioisotopes, is frequently used for this purpose. This substance concentrates in intensively working organs with large energy consumption. The ionizing radiation allows for following their function. Large energy consumption is also typical for the majority of malignant tumors. Imaging is possible thanks to the radioactive nuclei, the transformation of which is accompanied by emission of gamma radiation. In positron emission tomography, the nuclei-emitting positrons are employed. Positrons are antiparticles to electrons that annihilate with electrons in surrounding matter, producing a pair of gamma quants. Detection of these two gamma quants allow for determining position of their origin and three-dimensional imaging of an organ or tumor. Suitable radioactive nuclei are prepared by nuclear reactions of neutrons or accelerated charged particles with stable nuclei of a target. In the Nuclear Physics Institute is used for these purposes an accelerator called a cyclotron. It enables production of many medically relevant radionuclides in solid, liquid and gas targets. Each radionuclide may be prepared in one or in more nuclear reactions. A key parameter of the product is its radionuclidic purity. Moreover, a single medical radionuclide allows for imaging and treatment of various diseases, depending on its chemical form. A radionuclide must be incorporated into a suitable compound, e.g. into the above-mentioned glucose. Its amount in the compound must meet the requirements for good imaging quality. In the case of the short-lived medical radionuclides, one has to take into account also its loss during the transport to nuclear medicine departments due to its decay. In a hospital, a system of gamma radiation detectors enables to image a radionuclide's distribution in the body, or possibly in a given organ or body segment in detail. It is necessary to minimize a patient's radiation burden while keeping acceptable imaging quality in the diagnostics. The radiation burden is determined not only by the radionuclide selection, but also by its chemical form and by conditions during its production. The Department of Radiopharmaceuticals is focused on the investigation of novel medical radionuclides and their compounds for positron emission tomography and on innovative methods of established medical radionuclides production. Recently, we pay attention to copper radioisotopes and their compounds for both diagnostics and therapy, and to cyclotron production of technetium-99m, the most widespread medical radionuclide. A new cyclotron installed in 2015 will broaden also the research of new radiopharmaceuticals.